Okay, final lecture of the statics part of the course, and the only thing we're going to cover is Archimedes Principle here, and this will not take very long. So, key thing about Archimedes Principle, it doesn't actually depend on what's inside the object. It all comes down to the force distribution around an object. So conceptually, when people put an object under a liquid surface, it does one of two things. It either bobs up to the surface or it sinks. And if that object is exactly the same size and exactly the same shape, then the upthrust, or Archimedes force, is exactly the same. And the difference about whether it sinks or whether it floats purely depends on the weight of the fluid. So, as you probably know, if the thing that you're putting into the fluid is denser than the density of the fluid, then it's going to sink, and if not, it'll float. But this has nothing to do with the upthrust, or the force that pushes the surface up. It always pushes the surface up by the same amount, and that's down to the pressure distribution. So where does this come from? So the easiest way to think about this is you take a arbitrary surface and you put it underwater, and you work out the pressure distribution around this surface. So in my sketch here, I've got a surface and it's underwater, and the best thing to do is to divide it in two. So effectively, I want to consider the surface A to B to C, and then I'm going to consider the surface A to D to C, and I'm going to do a force balance. And if you consider the force A to B to C, then there's some fluid above it, and that fluid above it creates a pressure distribution on that surface. And if there wasn't any pressure distribution down here, these forces would push the fluid, push the object into the fluid, push it deeper. And so the forces on A to B to C are effectively downward pointing forces. And then you've got the forces generated on the surface from A to D to C, and these generally will push up because effectively the surface, the outside surface, has normals pointing outside. So, and the key thing is, if you think about the pressure at point B and the pressure immediately underneath it, there'll be a bigger pressure underneath it, and so therefore if you take a slice through this, a vertical slice through this object, and you take a pressure at B and a pressure immediately underneath it, there's going to be a bigger pressure underneath it, so the net force on this element is always upwards, and that's why this force is always called an upthrust. And when you do the integral, I'm not going to do this, but when you do the integral, you can work out the total upthrust, and that comes down to the density of the fluid, not, I stress, the object, the volume of the object, and gravity. Okay, so this is a force due to a pressure distribution over the surface of the object. It's got nothing to do with the force due to the weight of the object inside it. That's just the weight. And you have to think about the upthrust and the weight of the object, about whether this object is going to float, stay stationary, or sink. So there are three cases. So something's neutrally buoyant. It means it's going to sit in the fluid at whatever height you place it. And if it's a constant density fluid, then it doesn't matter at what height you place it. And if the density of the fluid is bigger than the density of the object, that means the upthrust is going to be bigger than the weight, and therefore the object's going to float. And if the density of the object is bigger than the density of the fluid, obviously it's going to sink. So when you put an object in a fluid, you've got two separate forces, and then you have to work out what's going to happen from there. Okay, fairly straightforward. So Archimedes' principle doesn't depend on what's inside the object. It depends on the pressure distribution around the side of it. And if you want to think about where the object's going to be, then we deal with floating, neutrally buoyant or sinking objects.